Hello my dear children, so I am back with the second video of the video series on understanding elementary shapes, class 6th maths, and in this video we are specifically going to talk about angles. And let me tell you, angles are the basics of shapes and they are very important concept. So please pay your attention and we are going to make this super duper easy and super duper fun for you. So are we all ready? Let's get started.
So let's say that the bottom surface is somewhere here and this is the lead. So both of them are oriented along the same direction. So there is no difference in their orientation when the box was closed. Now when you gradually start opening the box, you see that there is an orientation between the lead and the base. So base is along this direction but the lead is along this direction. When you totally open the box again, there is some kind of orientation between the two surfaces. So angle is a measure of orientation between two rays with a common endpoint. So in case of this lunch box, if you see, this is the common endpoint between this ray and this ray, right? So in the first scenario, and we measured this angle in degrees like 0 degree, 10 degree, 20 degree, 180 degree and so on. So let's look at the angle in each of these cases. So in the first case, the angle was 0. So this was the orientation of the base and this was also the orientation of the lead. So the angle between them was 0. So we call it as 0 degree. In the second case, if this was the base, if the blue ray represents the base, then the red ray represents the lead. So there was some angle. Now let's say, for example, this angle was 60 degree. Now when you opened it all the more, what happened? The value of this angle increased further. Let's say this time the value was 130 degree. So what are these? So these values are nothing but orientation between two rays. So in this case, rays are not the surfaces basically, but when you look at only this line, so that would be a ray. Only this line, that would be a ray. And both of these rays must meet at a common point. So you see, this is the common point here. This is the common point here. And we call this common point as the vertex. So this is the vertex. So this is about an angle. Now, where else do we use angles? Now, angles play a very critical role in direction. Now, when you talk about direction, we majorly talk about 4 directions: east, west, north and south. So every time you rotate by 90 degrees, you get a new direction. For example, let's say that you are facing towards east. You rotate in the anti-clockwise direction by 90 degrees. So this much is 90 degree. This is a right angle or a 90 degree. So where do you go? You face towards north. You further rotate by 90 degree. You face towards west. You further rotate by 90 degree, you face towards south. A further rotation of 90 degree brings you back facing towards east. So this is anti-clockwise. Now what is anti-clockwise and clockwise? Now have you ever observed in which direction the hands of the clock rotates? So they rotate in this direction. So this direction is called clockwise. That means like the clock. And when something is moving in this direction, then that is called anti-clockwise. That is opposite to the direction of the clock. So in this case, this movement was anti-clockwise. Similarly, when you move clockwise by 90 degree from north, you reach east. From east 90 degree clockwise, you reach south. From south 90 degree clockwise, you reach west. From west 90 degree clockwise, you reach north. So you see, in case of direction, angle plays a very important role. Now, when we talk about so many angles, now when we discuss about angles, we see that an angle could be 0 degree, an angle could be 90 degree, it could be 180 degree, it could be 240 degree, it could be 300, 360, it could be, is it that it could be any value? Well, the minimum value possible for an angle is 0 degree. 0 degree means there is no orientation between two rays. So if you have one ray like this, the other ray is also like this. So that means the angle between the two rays is 0. So this is the minimum possible value for an angle. Now what could be the maximum possible value? The maximum possible value could be 360 degree. Now what is this 360 degree? What does this correspond to? This means that let's say that one ray is like this. The other ray could be like this, where it makes some angle, maybe 45 degree. It could further increase to maybe 60 degree. It could further increase to 90 degree, like this angle is 90 degree. So in this fashion, it could increase, it continues to increase until and unless it comes back to its own position. And when it comes back to its own position, how much is the angle? 360 degree. So basically 360 degree corresponds to one complete rotation. Now when I say maximum value, that doesn't mean that an angle like 720 degree doesn't exist. So if I talk about 720 degrees, that means it corresponds to two complete rotation, because one complete rotation is 360, one more complete rotation is 360. So 360 plus 360 is 720 degrees. So it is not that above 360 degree the values for angles are not possible. The values are still possible, but in one complete rotation, the minimum value would be 0 degree, that is there is no orientation between the two rays, and the maximum value in one rotation would be 360 degree, because the moment you get rotated by 360 degree, you come back to the original position. So I hope that's clear now. Now the next question is, now between 0 degree and 360 degree, there could be many different angles. And in order to keep our study simpler, we have assigned different names to different categories of angles. Right angle. So this is a name given to the angle 90 degrees. So whenever the angle between two rays is 90 degree, we call it a right angle. Now there is another way of defining a right angle. It is that angle which corresponds to 1/4 of a revolution. That means you rotate something, you rotate a ray only by 1/4 of a revolution. 1/4 is nothing but 1/4. So not one complete rotation, just one part out of the 4 parts of one revolution. So one revolution is, let's say you started rotation from here and you completed one revolution here. Right? So 1/4 of this. So 1/4 of this would be only this part. So you see, only 1/4 of a revolution. That is a right angle. So it corresponds to 90 degrees. So this is the name that is given to this particular value of the angle. Similarly, you have something as straight angle. Straight because this angle is formed on a straight line. Now what is a straight line? This is a straight line. So this angle is 180 degrees. So the angle, the name given to the angle corresponding to 180 degrees is straight angle because it forms a straight line. Now the question is, how much of a revolution is 180 degrees? It is 1/2 of a revolution. So 1/2 of a revolution corresponds to a straight angle, that is 180 degrees. And finally, we have complete angle. Complete. That means one complete revolution. So one complete revolution would correspond to how many degrees? Yes, it would correspond to 360 degrees. That means you start from here and you come back to the same position. So that is 360 degrees, and this is called a complete angle. So it is very easy to remember. Complete means you completed one revolution. So it is complete angle 360 degree. Straight angle means it forms a straight line. So 180 degrees. Right angle. So here in this case, because you just covered 1/4 or 1/4 of the revolution. So these are the three names which are given to three specific angles: 90 degree, 180 degree and 360 degree. Now let's take the example of the clock to see the application of each of these angles. Have you ever observed how time changes in the clock? It's 3 o'clock right now. So what is the angle between the minute and the hour hands of the clock? So if you see, the angle is a right angle, that is 90 degrees between these two. Now, let's say that as time passes by, you often reach a time like this. What is the time now? It's 6 o'clock. And what has happened now? Now this hand of the clock has actually rotated further. So earlier it completed only 1/4 of the revolution. Now it completed half of the revolution. So it has formed a straight angle. Now again, as time passes by, what happens? From 6 o'clock it becomes 9 o'clock. Right? So from 6 to 9, again what happens? In this case, this hand of the clock has actually covered 3/4 of the revolution, if you look at it. Right? So it is gradually, this angle is increasing. So how much is this angle? This is not 360 degree because it hasn't completed 360 degree yet. So what do we call this angle? That we haven't learned yet. That what can we call an angle which is exactly between 180 degree, that is straight angle, and a complete angle. Okay, we will learn that in the next slide. And finally, the clock strikes 12. So actually this minute hand has, so this hour hand had actually covered one complete revolution. So now it has completed 360 degrees. So here this is your right angle, this is your straight angle, and this one is your complete angle. So when you observe the angle formed between the minute hand and the hour hand of the clock, so what do you see? You see that as time passes by, from 3 o'clock to 6 o'clock to 9 o'clock to 12 o'clock, the angle also keeps increasing. Now here I would like to bring to your notice a very simple thing which might create confusion in your mind. Now you might say that, okay, in this case we saw that the angle between the two hands of the clock was 90 degree. But when you consider this case, here also the angle between the two hands is 90 degree. But why are we considering this angle and we are saying that the angle is more than 180 degree? That's because you always need to remember from where you started counting. So I will give you one example. Let's say that you participated in a race. You are running and you have to cover, let's say, some kilometers by running, and you started from point A. So this is your start point. So you started from here and you have to reach a point B. So that this point is your destination. Now let's say you are running, you reached a point here. Again you ran, you reached a point here. So as time is passing, what is happening? The distance that you are covering is increasing, right? Now let's say that you have reached a point here. So now if I ask you that how much distance have you covered? So what is the distance that you would calculate? So the distance that you have already covered from wherever you have started, that is from point A, you will measure the distance that you have covered. Now instead of that, if somebody starts measuring your position right now from your destination point, will that give the right result? No, because your destination point is where you want to reach. But for whatever distance you have already covered, you have to measure the distance from your starting point. So the same concept is true here. So this was your starting point, right? So from the starting point, so you started measuring this angle from this 12 o'clock with respect to the hand of the clock corresponding to this 12 o'clock. So this was 0 degree for you and this was 90 degree for you. Now when this hand of the clock has moved further, so your angle has increased. Now this time also when it has moved further, you are still going to measure it with respect to this hand of the clock. So this time you are not supposed to measure it in the opposite direction. So you are going to measure it with the same reference. So you started measuring from here. I mean you always considered this as your baseline. So this was always one arm of the angle and you always calculated it in the clockwise direction. So clockwise direction it is 90, clockwise direction it is 180, in clockwise direction in this case it is 360 degree. So whenever you are measuring angle while rotation, make sure that you follow the same reference so that you do not end up doing wrong calculations. Okay, now the question is, we only named a few specific angles like 90 degree, 180 degree, 360 degree. But we also come across many other angles like these For example, on the screen, this angle could be say 45 degree. This angle could be 120 degree. So do we have names for each of these angles as well? Like how we call 90 degree as right angle. Do we have a specific name for a 45 degree or a 120 degree? So how do we name these angles? So this is where we talk about again 3 different types of angles. Acute angle. So this is acute angle, obtuse angle and reflex angle. So these are the 3 categories of angle names which take care of all the other angles except 90 degree, 180 degree and 360 degree. So let's see what are each of these. So acute angle, those angles which are less than right angle. That means the values of acute angles are always less than 90 degree. Anything between 0 to 90. 0 to less than 90 is acute angle. So this is an example of acute angle. So this could be 40 degree, 45 degree, 60 degree, 75 degree. These are all examples of acute angle. When we say obtuse angle, this angle is larger than a right angle but lesser than a straight angle. So right angle would be somewhat like this. So this is right angle. And what is straight angle? Straight angle would be like this. So this one is a straight angle. So anything between the right angle and the straight angle. So somewhere here. Now these angles could be examples of obtuse angle could be 120 degree, 135 degree, 140 degree, 150 degree, 179 degree. These are all examples of obtuse angle. So anything that is greater than 90 degree but less than 180 degree. That is obtuse angle. And finally, the third one, that is reflex angle. This angle is greater than a straight angle. That means it is greater than 180 degree, but it is less than a complete angle. That is 360 degree. So anything between 180 and 360. So where is 180? So if this is base arm of the angle, so this angle, this total angle would be 180 degree. And what is 360 degree? 360 degree would be this complete angle. So any angle that lies in this area, in this region, that would be a reflex angle. So examples of reflex angles could be 200 degree, 240 degree, 270 degree, 300 degree, 320 degree. These are all examples of reflex angles. So now with these 3 angle names, I think we have covered almost all the angles. Anything starting from 0 degree till less than 90 degree would be acute angle. After that we have 90 degree, which is the right angle. Anything greater than right angle but less than straight angle would be obtuse angle. Then we have straight angle, which is 180 degree. Then we have reflex angles, and then finally we have the complete angle. Now, if we try to describe each of these angles in terms of revolution, then we can say that acute angle corresponds to less than 1/4 of a revolution, because 1/4 of a revolution is 1/4 of a revolution. 1/4 of revolution is 90 degree. So acute angle means less than 90 degree, that is less than 1/4 of a revolution. Similarly, obtuse angle means more than 1/4 of a revolution and less than half a revolution, because half a revolution is 180 degree, so it is less than 180 degree, that is less than half a revolution, but it is more than 90 degree, so more than 1/4 of a revolution. So we can define these angles with regards to revolution as well. Now let us try to measure angles. How would we measure angles? Now for that, let us have a quick recap of whatever we have learned till now. So when we talk about measuring angles, let's have a quick recap of all the types of angles that we have learned just now. So let's start from, we will start measuring all the angles with respect to this line. That is, we will consider this as one of the arm of the angle. Now, any angle that is starting from 0 degree to 90 degree, to less than 90 degree for that matter. For example, an angle like this, it could be an angle of 30 degree. An angle like this, it could be an angle of 45 degree, or an angle like this, which could be an angle of 60 degree. So all of these are referred to as acute angle. The moment you reach the value 90 degree, you reach at right angle. So the angle corresponding to 90 degree is right angle. So anything more than 90 degree but less than 180 degree. So 180 degree is your straight angle. This is straight angle. So all those angles which comes in between 90 and 180, that is, this is the angle. Similarly, this is the angle. So all of these angles are referred to as the obtuse angles. Now all the angles beyond 180 degree but less than 360 degree. So all of these angles. So if when you talk about this angle, it is this angle. Similarly, when you talk about this angle, it is this angle. So all of these angles, they fall under the category of reflex angles. And finally, when you complete one rotation, you reach complete angle, which corresponds to 360 degrees. So these are the various types of angles that we have learned. So how do we measure an angle? We measure it using a protractor. Now you would have seen a protractor inside your geometry box. So now we will understand how we make use of a protractor to find the measurement of an angle. So we will learn it step by step. So let's say that you are given an angle and you need to measure it. So the first thing that you need to remember is the midpoint of straight edge of the protractor lies on the vertex of the angle. So this is your protractor, this is the straight edge, and this is the curved edge. So the straight edge has a midpoint, this point. So we need to make sure that this point lies exactly on the vertex of the angle. So let's take example of this angle. Let's suppose that you have to measure the value of this angle. This is the vertex of the angle. So we have placed the protractor in such a way that the vertex of the angle and the midpoint of the straight edge of the protractor, they both coincide. So that is how you have to place the protractor. That is the first thing that you need to remember. The second point that you have to remember is straight edge of the protractor is along one arm of the angle. So these are the two arms of the angle. So one arm of the angle should be along the base line of the protractor, that is the straight edge. This is the straight edge. So the straight edge should lie exactly on one of the arms of the angle. So these are the 2 points you need to remember. If you do not place the protractor correctly, then the measurement of the angle that you would get would also be incorrect. So these are 2 important things: midpoint on the vertex, straight edge along the arm of the angle. Now once you have placed it correctly, start reading from 0 degree. For example, in this protractor, where is 0? 0 is here. Make sure that this 0 mark coincides with the straight edge of the protractor. So the straight edge of the protractor and this 0 mark, they should also lie along the same line. So start counting from 0. Now you see where is the other arm of the angle. So the other arm is here. So see, where is it? It is between 70 and 80. So somewhere exactly between 70 and 80. So that is 75. So that shows that the measurement of this angle is 75 degrees. So let's take one more example. Let's say that this is an angle which is given to you and you have to find its measurement using a protractor. So how will you place the protractor? This vertex should coincide with the midpoint of the straight edge of the protractor. So this is the midpoint of the protractor. So both of these should be at the same place. Fine. Also, the straight edge of the protractor and one of the arms of this angle should also coincide. So therefore we will place the protractor in this fashion. Now let's start counting from 0. So where is the other arm of the protractor? At 30. So that shows that the angle here is 30 degrees. So based on all that we learned about angles, let's try some questions. Question number 1. Where will the hand of a clock stop if it starts at 12 and makes half a revolution clockwise? So that means the hand of the clock is at 12. So from where it is going to start. Now it makes half a revolution. So how much is half a revolution? So one revolution is 360 degree. Right? So we know that one revolution corresponds to 360 degree. So half revolution would mean half of 360 degree. That is 360 degree divided by 2. That is 180 degree. So how much is 180 degree? 180 degree is nothing but 290 degrees, right? So this clock, and it also moves in the clockwise direction. That means this is the clockwise direction. So this is how, let's see how it rotates. This is how it will rotate. So let's look at it once again. So if we divide it into 4 segments, so 190 degree in the clockwise direction will come here, another 90 degree in the clockwise direction will come here. So 180 degree in the clockwise direction will bring the hand of the clock to 6. So therefore the hand of the clock would stop at 6. Let's look at the second part of the question. If the hand starts at 2 and makes half a revolution clockwise, again clockwise, but this time it is starting at 2. So let's again divide it into 4 equal halves like this. So this time it is already here. So that means it has to cover 290 degrees. So how will it cover 290 degrees in this case? So here 190 degree would take it somewhere here. So this would be 190 degree, and again another 90 degree would take it somewhere here. Now, so this would move in the clockwise direction, again in the clockwise direction. So let's see where it reaches. So finally this hand would reach at 8. Right? So 190 degree, another 90 degree. So together it is 180 degrees. So another interesting thing that you can observe is after getting rotated by 180 degree, it will form a straight line, right? So if this is half of that straight line, the remaining half has to be this. So just by looking at that also, you can see that it will reach the number 8. Question number 2. Which direction will you face if you start facing west and make 3 by 4 of a revolution anti-clockwise? Okay, first let us see what are the 4 directions that we have: north, south, east and west. So it says that initially you are facing west, right? That's what the question says. That means this is how you are pointing initially. Now this arrow head shows that your face is towards the west. Okay. Now what you do, you make 3/4 of a revolution. So can you tell me how much is 3/4 of a revolution? So we already know that one revolution corresponds to 360 degree. That is the complete angle is one revolution. Okay. So 3/4 of revolution would be 3/4 of 360 degree. Right? So now if you calculate this, you would see this is 90 degree. So that is 3 into 90 degree. So basically it is 3 times 90 degree. So when you actually start the revolution, you make 390 degrees. So 3 right angles you need to complete. And in which direction? In anti-clockwise direction. Okay. So what is anti-clockwise? This is clockwise. So this is anti-clockwise direction. So when something moves like this, that is anti-clockwise. So let's make this arrow move in the anti-clockwise direction. That is in this direction. For how many degrees? For 390 degrees. So which are the 390 degrees? So if we divide it into 4 quadrants, this is 190 degree, this is second 90 degree and this is third 90 degree. So when it actually starts rotating, where will it end now? So it reaches towards north. So that means now you will face towards north. So if you start from west, make 3/4 of a revolution anti-clockwise, then you would reach towards north. Okay, so let's look at the second question. You are facing south and you make one full revolution. So by mistake I have written it here, so now it's not visible properly, but yeah, it says you start from south and you make one full revolution. Okay, again we have our directions. So initially you are facing towards south. So one full revolution. So full revolution means how much? Full revolution corresponds to 360 degree. So that means you will start from here and you will make one complete angle. So the moment you make one complete angle, where do you reach? So you reach back to the same position. So you started from south, you started facing south, you came back facing south. So you will come back to your original position after one full revolution. Okay. So it says that. So these are the 4 directions that we have. So it says that initially you start facing south. So correct initial position is towards south. Perfect. Now you turn clockwise. So what is clockwise? Clockwise means along the direction of the hands of the clock. So this direction. So you actually move like this. Like this. Perfect. And then you turn clockwise towards west. So you need to reach till here. So from here till here. So how many right angles do you make? So from south to west in this direction, how many right angles are involved? Only one right angle. So let's see how would it move. It would move like this from south to west. So how many right angles did we cover? We covered one right angle. Let's look at the second part of the question. It says you start facing north. Okay, so we are currently facing north and turn anti-clockwise to east. So anti-clockwise would be like this. So let me change the color of the ink to get for a better visualization. So now this time you are going to move anti-clockwise. That is in this direction. Perfect. So from north you have to start and you have to reach east. So that means you start from north and you rotate till you reach east. So how many 90 degrees did you cover? So this is one 90 degree. This is one more 90 degree. This is one more 90 degree. So basically you covered 3 right angles. So 3 right angles were covered in this case. So whenever you have to handle the questions on directions, make sure that you draw this. Without drawing this, it is very difficult to answer such questions. Let's look at the third one. You start facing west and turn to west. That means your initial position was towards the west and you have to come back to the same position. Now whenever you have to come back to your starting position, how much rotation do you need to do? So you need to complete one complete revolution. So you start from west, complete 360 degrees and come back. So 360 degrees have how many right angles? 1, 2, 3 and 4. So in this case you covered 4 right angles. Let's look at question number 4. Where will the hour hand of a clock stop if it starts from 6 and turns through one right angle? Okay, so the hour hand. So here we have just shown the hour hand of the clock to avoid any confusion. So this is your hour hand and it starts from 6. It turns through one right angle. Now can you tell me that why is it not mentioned here whether it will turn clockwise or anti-clockwise? That's because it's a clock. So a clock will always move in the clockwise direction, right? So this time it would move in the clockwise direction, which is which direction? This direction. So it will actually move like this. So the rotation would always be like this, in this direction. So it starts from 6 and then turns through one right angle. So let's again divide it into 4 quadrants. So that makes our job a lot easier. So now you can very easily tell where will it go. So it starts from 6, completes one right angle. So it reaches where? It reaches 9. So this would stop at 9. Now if it starts from 8 and turns through 2 right angles, let's see what would happen in that case. So it started from 8 and it completed how many right angles? 2 right angles. So 2 right angles is how much? 1 right angle is 90 degrees. So 2 right angles is 2 into 90 degree, that is equal to 180 degree. So what is 180 degree? This is a straight angle. So very simple, it started from 8 and after rotation, it will make such an angle that it forms a straight line. And in order to form a straight line, where will it reach? Absolutely, it will reach at 2. So 2 would be the end point. So in this case, it will reach 2. It will stop at 2. Now, even before we take a protractor and start seeing the actual measure, just by looking at the angles, what do you think? Which will have a larger measure? Now, measurement of an angle is all about the inclination of the 2 rays. So for angle A, if you see that the inclination of the two rays is lesser, right? But in angle B, the inclination between the two rays is more. So we are expecting angle B to be larger than that of angle A. Now let's make use of a protractor. And only with a protractor we can tell the exact measure. So I hope you remember the two important points while measuring with a protractor. First point, the midpoint of the straight end of the protractor should coincide with the vertex of the angle. Perfect. The second point is that the straight edge of the protractor should lie along one of the arms of the angle. That is also perfect here. And from where will you start the measurement? From the 0. So this is the 0. Now see here in this protractor there are two scales. One scale is 0 starting from this side, another scale is 0 starting from that side. Why? Because in this case we want to measure this angle. So we have actually coincided the straight edge of the protractor with this arm of the angle. So we need to start measuring the angle from this arm. So you remember point number 3, that the 0 mark on the protractor should lie on this arm of the angle. So this 0 mark is lying here, so we will start measuring from here. So we see that this line comes at 40. So that means the measurement of angle A is 40 degree. So measure of angle A is 40 degree. Now let's measure angle B. Again the same tips. The center coinciding with the vertex, the straight edge coinciding with one of the arms. Now in this case, when you see the measurement, you see the measurement is slightly more than 65 and slightly less than 70. Now here, since we are just showing you through animation, so when you actually do it, maybe it will come approximately 70. So let's assume that the measurement is approximately 70. So which is more? So we see that measurement of angle B is greater than measurement of angle AA. So whatever we had guessed was right. Question number 6. Find the angle measure between the hands of the clock in each figure. Okay, let's first focus on the first figure. So here we will have to find out the measure of this angle. So let's place the protractor correctly such that the midpoint of the straight edge coincides with the vertex, and also the straight edge should coincide with one of the arms of the angle. So where is 0? This is 0 because 0 coincides with this straight edge of the protractor. Okay, now let's see where is the other arm. So the other arm corresponds to 30 degree. So that means the measure of this angle is 30 degree. Let's move on to the next one. Here we see this is a straight line. So that means a straight angle. So if you look at it, you see both the arms of the angle are coinciding with the straight edge of the protractor, which very clearly tells us that this angle is nothing but 180 degrees. Question number 7. Measure and classify each angle. So we are given this table, so we have to find out the measurement of each of these angles and also what type of angle is this, whether it is acute angle, obtuse angle, right angle, or what kind of angle. So first one is angle AOB. So this is angle AOB. So again we will place the protractor, midpoint of the protractor coinciding with the vertex of the angle. So when you measure this angle, how much is this? This is 40 degree. So this angle is 40 degree. So its measure is 40 degree. Can you tell me what type of angle is this? Its value is less than 90 degree. So this is acute angle. Next one is angle AOC. So even for angle AOC, we will place the protractor in the similar way. And here if you look at angle AOC, you see this is angle AOC, right? This total angle. So this corresponds to 125 degree. So therefore angle AOC is 125 degree. So what type of angle is this? This is obtuse because it is greater than 90 but less than 180. Third one is angle BOC. So BOC would be this angle. So we have to place the protractor in this fashion such that it coincides with the arm OB and the midpoint should coincide with the point O. So with this we see that this angle is between 80 and 90. So this point corresponds to 85 degrees. Right? So this angle BOC is 85 degrees. So what type of angle is this? This is also less than 90 degrees. So this is also acute angle. So in a similar fashion, I hope that you can find out the values of angle DOC, DOA and DOB. So that is left as an exercise for you. So keep placing the protractor and try to find their values.
I hope you found the video useful. If you really liked the video, do not forget to share it with your friends. And if you think after watching this video, your concepts of this lesson became crystal clear, please do write in the comment section that my concepts are crystal clear. So I will meet you all very soon with a new video, with a new topic. Till then, stay home, stay safe, take care. Bye-bye.